Hello all. Sorry for the lateness of this video, but it's better late than never. And if you don't get the opportunity to watch it, well, we will go over some of this in class as well. So let's get cracking straight into it. And today we're looking at the inverses of exponentials and logarithms, which so happens to be each other. So the inverse of an exponential is a logarithm, and therefore the inverse of an exponential is the inverse of logarithm is an exponential. A key thing to remember when we're doing the inverse, if we're thinking of transformation of a mapping, we're just switching our x and our y values. So that's that way that we can go about the process, switch x and y values, rearrange to isolate y again, and then write it as an inverse function. And that's a really key thing that you will get hammered on in the exams mark-wise. If it asks for an inverse function, you need to write it as an inverse function notation. So let's get straight into it. First example is find the inverse function of f of x is equal to e to the x plus 3, and state the domain and range for the inverse function. So first off, let's try and find the inverse. So we have the equation y equals e to the x plus 3, and we just want to switch our x and our y when we think of a transformation. So we now get x is equal to e to the y plus 3, and now we just need to rearrange to get y by itself. So let's go x minus 3 is equal to e to the y, and then we'll just take the log of both sides. Now, in this case, it's pretty straightforward. We'll take the natural log of both sides because we have an exponential of base e. So let's do that. So we get log base e of x to the minus 3 is equal to log base e of e to the y. And to show the full working, just to remind you why this effectively cancels, is using our log laws. We're looking at this y here. Since it's log of base e to the power of y, that y we can, using our log laws, take out the front. So we end up with something like log base e of x minus 3 is equal to y log base e of e, and the log of base e of e is just 1. So that ends up cancelling out, and we're left with that. Now, you can't leave it like that. That's just an equation. We're actually asked to find the inverse function, so we need to write this as an inverse function, which is f to the negative 1 of x is equal to log base e of x to the minus 3. So that's our inverse function. Now we do need to state the domain and range of the inverse function. We could look at this and think of how the basic log function is being transformed. That's one way to approach it. So just remembering that an exponential function runs like this, has an asymptote at x equals 0. A exponential runs like that and has a asymptote at, this one over here was at y equals 0. That one was at y equals 0, and the log has an asymptote at, at x equals 0. Okay, so we could then look at this, look at our h value, notice that it's translated left or right. The other way we can do it, and there'll be a reminder on the next page, is that the domain of f is equal to the range of the inverse, and importantly, a really handy thing generally when we're actually solving problems is it's the range of f informs us of the domain of the inverse, because we generally care about domains of function mainly because that's telling us our restrictions of what our inputs are, and that's the whole point, is we're trying to put input into a function. So either way is fine, but looking at this log, we can clearly see that h is equal to 3. So the graph is being translated right 3 units in the positive direction of the x-axis. So everything in blue on this little sketch has been moved right 3. So it comes up over that way. So we can clearly see that the domain of inverse of x is equal to x being greater than 3. It can't be 3, but it can be greater than 3. And the range of f of x is equal to all real numbers. Because it goes to negative infinity and up to positive infinity. So that's that question done. So if you wanted to write it as a full final function, no, inverse we won't write as a full function notation following all of this. We'll just leave it as, because the questions actually sort of ask for the domain and range separately. So you won't write it with domain and codomain. Right here, so as I mentioned briefly, checking domain and range, we want to be able to remember and recall the shape of the exponential and then log graphs, and just remember that they're inverses, and think about how those domain effects. So coming in that we have, didn't change color. We have that asymptote for the exponential, like I said on the previous slide. And then we also have this asymptote for the logarithmic graph. And then when we find the inverse of one, when we go from one to the other, the domain becomes the range and they switch, just like I talked about on the previous slide. A lot of the times you might also just be asked to just rearrange, or the big thing will be rearranging the equations, also called transposition of equations. So this is sort of, I guess, a skill leading into how can we rearrange our equations, and then that's going to help us with finding our inverses. So just use this more of a bit of practice. So we're asked to rewrite the equation y equals 5 log to the base e of x minus 2 with x as the subject. So that means get x by itself. So we're not technically finding the inverse here. We're not switching our y's and x's or anything like that. It's just asking to rearrange the equation. So first off, we're going to get y plus 2 is equal to 5 log base e of x. And then we will get divided by the 5. So we get y plus 2 divided by 5 is equal to log base e of x. And now that we've got a log and we're trying to effectively undo the log, we need to do the inverse of it. So we are going to make it to the make an exponent with base e. So we get e to y plus 2 on 5 is equal to x. So we've effectively applied our, because when we're doing opposites, what you're technically doing is inverse operations. You're using the inverses of an operation. So when we have a log, we use the exponent. So that's that one. Okay. Rewrite y is equal to 3 by 8 to the t with t as a subject. If you hear that crackling noise, that's just my kitten rumbling around. So again, rearrange it to make t the subject. So first off, we're going to get y divided by 3 is equal to 8 to the base t. Now, you could do log base 10. You could do log base e to undo, but it's much simpler to choose the base of what's under the exponent. Will make your life a lot easier. You can technically do log of base 10 and then change bases and all sorts of things, but this is a much simpler way to go about it. So from here, we're just going to take the log of base 8 of both sides. So we get y on 3 is equal to log base 8 of 8 to the t. And similar sort of thing to the very first slide. What we want to do is using that log law, we can bring that in front. So we now get, change color. Log base 8 y on 3 is equal to t log base 8 of 8. Log base 8 of 8 is just 1. So we get t is equal to log base 8 of y on 3. Is there anything more we can do here? That's a division, so I guess technically you could go, let me double check the log laws before I lead you all astray. Where'd they go? Here we go. Yeah, we have a division. Okay, so we can turn it into a subtraction like that. So we could turn this into log base 8 of y take away log base 8 of 3 if you wanted to. If you really wanted to, you could then change the bases of this and end up as a fraction, but there's no real point. Leave it as that. That's completely fine. So yes, yep, and there we go. That's it for this video. Again, apologize for the lateness, but nice, short and sweet. The big thing is just remembering that we can log and an exponent are the inverse of each other. That's it. See you in class and have a good evening.